Now let us go through example 10. We are asked to sketch the graph of this cubic equation and to deduce the graph of modulus of fx. So this should be pretty straightforward. Okay, we have the graph over here and we can label all the intercepts in order to help us, pin down the graph. Then because we are sketching the graph of modulus fx, we think back to the definition for the modulus function, and the positive regions are going to stay the same. So what we do is we sweep through the entire graph to identify the positive y region. So that was the one that we just saw, okay, this yellow highlight. So we will literally keep those portions of the graph, right? Meanwhile, for the portions that are below the y-axis, which is over here, we will have to do the reflection about the x-axis. So we will proceed to draw those portions that are reflected upward. And this is our graph of y equals to modulus fx. Okay, I think this should be fairly straightforward and simple. Now, if we try to extend the discussion and think about how to obtain this graph of y equals to negative of the modulus of fx, then we see that there is going to be more than one kind of transformation involved here. The first one is quite obviously the modulus function, right? So modulus of the fx. But the second one is to introduce this negative 1 over here. Okay, so there are two transformations involved here. One is to sketch the graph of y equals to modulus of fx. And then, in order to get this negative of the modulus, what we have to do is to reflect about the x-axis again to get y equals to negative of this modulus, right? I hope this makes sense to you because you can see that the modulus function always give you positive values. So that means this portion, right, without the negative sign, this is always positive. And therefore, when you try and multiply a negative 1 to it, it must be entirely negative. Okay, that's it for this example.